We are live. So in this video, I'm going to talk about using cross-validation and k-fold validation for determining different kind of machine learning models. And this is kind of a useful technique when you're evaluating different models on a data set, and you want to make sure that you're not kind of overfitting or underfitting your data and so on. So as before, we have NumPy, Matplotlib. Actually, we don't need randNormal. We're going to use our support vector classifier. I also throw in a random forest classifier. And the big ones we're going to use here is train test split, k-fold, cross-val score. And we're also going to work on a real data set. So let's do load iris. And so what we can do is we can do data is equal to load iris. And this is kind of a built-in function. And if you want to take a look at this, so if you look at data, basically we're going to have a dictionary. And so we're going to have the data value in here. So that's kind of the data, and then there's going to be all kind of information in here, targets, and then kind of information. Easiest way to do this is kind of come back up here, and I'm just going to do print. And then I can do data, right? And then because we're a dictionary, it's going to be description. And if you read this, it kind of prints it out nicely. But basically, this is kind of a classic data set that was I think it was generated by Fisher like 100 years ago. And it's just basically information on kind of sepal and petal width of different flowers. And basically, you could classify based on this kind of the length of these characteristics of the plant. He could classify them based as one of three different types of plants. And so we have actually 150 data points, right? 50 for each three classes. So Iris setosa, Iris versicolor, and Iris virginica. I apologize if I'm mispronouncing that. And, we kind of have our four attributes, right? So these are our four attributes. If I want to get the data, it's kind of nice. So I can just do kind of x is equal to data.data, and then y is equal to data.target. And if I just print out, let me just get rid of the description here. And so I can print, basically, if I take a look at the X data set, basically it's just a matrix, right? So each one of these is each row is a different instance, and each column represents the attribute. So this would be the first sample. This is the second sample, and so on. And then if you look at the Y value, you're going to see it's 0. So this is the first type of plant here. This is the second type of plant, and then here's the third type of plant here. So there's a number of data sets that are in sklearn, and this is just kind of the way you load them. And in your homework, I have you go through a bunch of data sets kind of built into sklearn. Next week, we're going to actually use kind of external data sets, and I'll talk about pandas, which is kind of like, it's almost like a spreadsheeting program within Python. So if we want to kind of do kind of a classification, right, we could just do, again, we could do like SVC. And then what we could do is like an SVC, and then we can do kernel, and then we can have a linear kernel. And then we could do SVC, we could do fit, x comma y, and then, we could look at SVC score, right? And so you find that does 99% of kind of the accuracy, right? So 99.3% of the points, I think it's all but one, we're able to accurately classify. Now the problem is we're training our data on our model on the full set of data, and often what we want to do is hold out some data to kind of test the model, because if you try to fit something to all the data points, you can get into overfitting. I'll do a separate video on overfitting. It'd be easier in 2 dimensions where we can visualize the data. I'll also talk later how we visualize multidimensional data, but that's not going to be covered this week. And so what we're going to do is we're going to try to split our data into a kind of training and test set. So the best way to say this is, imagine I have NP, and let's do kind of like a range of 10. And so if I just print X, what you're going to get is it's going to be 0, 1, 2, 3, 4, 5, all the way to 9. And so what I can do is I can use this function. So I can say like X train x test is equal to train, test, split. And then I'm going to pass an x, and then I'm going to set the size is equal to 0.5. And what I'm going to get back is two, what did I do? Test size, I'm sorry. Test size here. And then I can do like print x of train. Let's call this x train. This is x test. So training is what we're going to use to fit the model, and then we'll separately do kind of validation on that. So we have train, and then we can do print x test, right? And so what it's going to do is take that initial number, and it's going to randomly assign half the points to the training set and half the points to the test set. And if I did like 7.5, right, it's just going to change the different things, right? So here's the train, and here's the test, and here's the fraction of the data points that are going for a test size. But let's just do 5, right? So in our problem, what we're going to do is do a little bit different, right? So let me come down here. Let me clear this out. This is the problem of using x's, so let me load my data. And so what we're going to do is we're going to have a support vector classifier. Let me clear this up and clear this out. And what we're going to do is we're going to split this up into our x train, and then we're going to do our x test, and then we're going to do our y train and our y test. And this is going to be train, test, split. And now we're going to pass in our x and y, and we're going to do test size equal to 0.5. And so if we just print like x train and print x test, right, what we're doing is we're splitting up our data set. So our training data set is going to be an array. It's going to come down here. And so half of our step is going to be in the first array. And then for our test is going to be the second array where we have the other half. So that's kind of how we can visualize it. And so what we can do is we can do SVM, right? Support vector machine. We can do fit, right? And so we're going to do train and then Y train here, right? So that's when we're fitting our model. Oh, SVC, I'm sorry, right? And then once we fit our model, we can evaluate it on a separate set of data, which we're holding out, which is our X test and our Y test. And I don't want to train this, I mean the score here. And I can print out the score, right? In this case, it's going to be 97% accurate. So it's not as good, but it's still pretty good for the model. And likewise, we could do a random forest, right? And I can come up here with a random forest classifier. All right, so I'm going to come over here. You know, sometimes you might want to pass in parameters. So typically when I do random forest, you can give it the number of estimators that you want, right? And so I mentioned these are ensemble methods, which means basically you create lots of models. And so maybe we'll create 1,000 models. Right, and then basically what we're going to do is pull all those different models on our data and see kind of the average score for it, which is kind of roughly what the algorithm does. So we can do fit, we can do X train, and then we can do Y train. And let me print up the score here. And then we can also do print random forest, and then we can look at the score on the X test and the Y test here. And so, and estimators, I think. Whoop. And it's thinking, and actually both of them do just as well on here. So they're both getting 97.3. So evidently 1 point is kind of problematic with this data set. So that's kind of one way to do kind of cross-validation. There's another one we're going to talk about, which is using k-fold validation. So let's just do x is equal to NP A range here. And I'm going to do 10. And this is just going to be a number, right, if I look at x. Right, that's a number from 0 to 10. And so what I can do is for train. So what I'm going to do first here, let me set this up. I always forget to do this. So we're going to do k-fold is equal to k-fold. And then what we're going to do is we're going to do n splits. Let's do 5 splits, right? And so then I can do for train and test in kind of k-fold split, right? And obviously we can put more variables in it, but I can print, right, train test. And what it's going to do is take the first, here's my initial data set, and what it's going to do is split this into 5 data sets, right? And so the first I'm going to hold out the 0, 1 point for my testing part, and then I'm going to use the other 8 data points for the training part. And then the next time I'm going to grab the next 2 data points for my test and use the other for the train, and so on. And what we're going to do with all this is we're going to apply our model to all 5 data sets, right? So we'll try it on this one, right? So here's our train, here's a test, we're going to get a score, train, test to get a score, train, test to get a score, and then we can take an average of all those scores. And that's kind of like k-fold validation. It's a little bit more kind of intensive than just kind of splitting our data set in 2. And so here we can split in 5. We can also, if we want to shuffle the data, rather than do it kind of ordered, we can do shuffle is equal to true. And we're going to kind of shuffle our data set. All right. So let me just grab this up here. Right. So we have our data set, right? Because I've overwritten the x. That's why I'm going to grab the data here. Right. And so what I'm going to do is I can do kind of my k-fold validation. So I'm going to do k-fold is equal to k-fold, and then we'll do n of splits. And now I'm just going to do 4 splits here. And then maybe I'll do shuffle is equal to true. And then what I can do is I can do for train and test in k-fold split. And now we're going to split the x. And what it's actually not going to do is not going to split the data. It's actually going to, these are going to be the indices for the data. So if I come up here and I did like NP rand of 10, all right, rand normal, I'm sorry, whoop, rand normal of 10, I just need rand normal. So here I have kind of my rand normal. This is just giving me the index values for this data. So it's actually not, unlike this case where we're splitting the data with test and train, here it's just giving me the indices for this. But anyway, if I was going to do this algorithm, I could do like SVC, right, my support vector classifier. I'm going to do fit, and then I could do X of train, and then Y of train. So these are the values I'm going to use for the train. And then I can print SVC score of X of test, and then Y of test. And why am I not getting k-fold? Oh, I forgot the big F there. And so you're going to see we do 4 of them. And the first one is 97. It's actually the same as the second. Then we get 1 and 1. We could also try 6. Right? And so we're getting different kind of data sets here. And so this is another way. And then we could take all these and average them up for the different models. We could also take a look at if we use our random forest classifier. Right? So here's our random forest. Takes a little bit more time. We get 96, 92, 1. So it's 100%, 92, 100, and then 96% accuracy. And again, this is mean they're classifying it correctly on the test data set. Now, one of the nice things about Python is that this is kind of annoying to do. And so what we can do is we can actually kind of basically just run all of this in one line, so to speak. So what I could do is do d-scores. And then what I could do here is I could do cross val score. I'm going to pass in my algorithm, which is support vector machine. Support vector classifier. Pass in my x, my y value. My cross validation, I'm using k-fold, right? And we already defined k-fold. Actually, I can come up here and define it. So there's my k-fold here. And then the last one is typically we're going to do this n jobs minus 1. And I think this is just prevent parallelization, if I remember correctly. So I run this. It's going through all the algorithms. Oh, let me just print this. Print d-score. Print d-score. Now it's just returning these numbers to me in kind of one line. So I don't have to loop all this. It just kind of runs it exactly where I pass in kind of the algorithm I want to use. I pass in the data, I tell it the k-fold, and then I have this option, which is just the number of jobs. And then that just, because we're splitting up the data, we can send it to multiple cores. And then I could also do the second line. I could print this d-score, and then I can come up here, and then I could do, random forest. And that's going to be the first one. And then in the second one, I have my data for the random forest. Now, what you can do with this in the samples, what I've done is I've done examples where I've changed degrees and polynomials in a loop. And this is just an easier way to kind of do all this in one line. So there's a lot of these kind of pipeline functions in sklearn that does everything for you kind of in one step, so to speak, in one line. So basically this over here is basically the same as this code. Right here I would just do like dscore. I could do score dot append, right? And I'm just going to append this value, and then I'm going to set score is equal to empty, right? And then I can just come down here and print score. And where's my syntax? I must have an extra parenthesis. Let's see if that runs. It's running through here. So thinking. And now I just get it back. So basically this down here does it in one line, right? Obviously, because we're shuffling our data, we're not going to get exactly the value. But typically people do these k-fold validations where you're kind of reevaluating your model multiple times to compare different models. It's also useful because there's a lot of parameters in a lot of these algorithms. It's kind of beyond the scope of this class to kind of get in the details of it, but you can read the documentation. And you can basically put a loop around here and compare the scores for different parameter values. Hopefully this is clear, and this is basically what I'm asking you to do in your homework, right? When you compare the different algorithms, what you can do is basically you can print like, NP mean here would be k-fold. For support vector machine here, we could do NP mean d-score. So that would be kind of the mean value. So here on average it does 96, and slightly better with the support vector classifier versus the random forest. What you'll find is these algorithms only vary maybe 5 or 10%, at least the good ones, though sometimes they can abruptly fail in certain instances, which you'll see maybe in the homework and in some of the examples that I posted on Compass. With that, I'll stop. If you have questions, please put them in the comment section, post in Piazza, or fire me an email or bring it up in office hours. All right, thank you.